Hi, good day. My name is Megla Ravichandran and my metric number is CN200164. Today I am going to present about my PSM1 title, which is Non-Woven Mat from Palm Empty Fruit Bunch PEFB and Bamboo Fiber at Different Ratios. My supervisor name is Dr. Nick Noor Munira Binti Mat Hassan. My project proposal is to make a non-woven mat from PEFB fiber and bamboo fiber at different ratios. Palm empty fruit bunch PEFB fiber wastage occurs when the fibrous material derived from discarded oil palm fruit bunches is not utilized efficiently or properly. PEFB fiber is a byproduct of the palm oil industry and has a potential as a useful biomass resource. Inefficient handling and disposal of PEFB fiber can render it unproductive and have negative effects on the ecosystem. Similarly, bamboo plant material can be wasted or disposed of inefficiently during various processes. Bamboo's low cost make it a popular scaffolding material, but improper disposal poses environmental risk. PEFB fiber and bamboo fiber are actually natural fibers that can be used in the production of textile mats. If we see, PEFB fiber has excellent mechanical properties and high cellulose content, making it suitable for non-woven mats. Natural fiber reinforced polymer composites have the potential to replace synthetic fibers and reduce their environmental impact. So, non-woven mats combining with bamboo fiber and PEFB fiber can reduce wastage and noise in the ducting system. Non-woven mat made from PEFB fiber and PET yarn reinforced epoxy exhibit improved mechanical characteristics. Thermoplastic composites reinforced with bamboo fiber also show qualities such as low density, high toughness, specific strength, biodegradability, and renewability. The non-woven mat made from bamboo fiber and PEFB fiber provides sound absorption benefits in ducting system. The interlaced fibers in the mat create a thick and porous structure that efficiently capture and dissipates sound wave, reducing noise pollution. In short, the non-woven mat is eco-friendly due to the sustainability of PEFB and bamboo fibers. There are two main problem statements that can be identified in this study. The first issue is a significant amount of waste produced by the palm oil and fiber sectors which is not being used well and can have negative environmental effects. Empty fruit bunches from oil palm trees are one of the solid waste generated by CPO, crude palm oil, mills that have not been brought to commercial use. Besides that, the search for creative solutions to use leftover bamboo fiber has generated more attention in recent years. Some businesses explore the potential for reprocessing discarded bamboo materials to create different valuable goods like biofuels or composite materials. Furthermore, the construction sector, which presently significantly depends on non-renewable resources, is seeing an increase in demand for sustainable insulation materials. Installing diffusers or slow-speed HVAC equipment above the exhaust outlet can cause some noise in building HVAC engineering. So, converting this waste into an efficient insulation material not only addresses the issue of environmental concern but also meets the increasing demand for sustainable building materials. The first objective of this study is to determine the water contact angle of non-woven bamboo fiber and palm empty fruit bunch at different blend ratios before and after silent coupling agent treatment. The second objective is to characterize sound absorption, damping ratio and thermal conductivity for non-woven bamboo fiber and palm empty fruit bunch at different ratios. The first scope of this study is by using silent coupling agent of treatment for bamboo fiber and palm empty fruit bunch and focus on characterizing the water contact angle above 120 degree. The second scope is ASTM C423 is used to classify the sound absorption. ASTM E756 is used to describe the vibration damping properties, and ASTM C177 is used to measure the thermal conductivity of a material. For the literature review part, article named Acoustic and Thermal Performance of Polypropylene Non-Woven Fabric for Insulation in Buildings from year 2022 is choose to reviewed. The summary of the article is PP non-woven fabric have great potential as candidate materials for building applications due to excellent chemical and corrosion resistance, very low moisture absorption, low density and the ability to engineer thermal and acoustic properties. These fibrous structures can be placed on walls or ceilings to control and reduce noise and heat transmission. The second article is named Potential of Oil Palm Empty Fruit Bunch (PEFB) and Sugarcane Bagasse Fibers for Thermal Insulation Application from year 2021. The items that The second article is Potential of Oil Palm Empty Fruit Bunch (PEFB) and Sugarcane. The second article title is Potential of Oil Palm Empty Fruit Bunch (PEFB) and Sugarcane Bagasse Fibers for Thermal Insulation Application from year 2021. The item that they discuss in this article is OPEFB fiber reinforced polymer composites have higher porosity, which leads to lower thermal conductivity, a much desired feature for thermal insulation materials. The lower the thermal conductivity value, the better the performance of the insulation material. The sound absorption ability of a material influences acoustic comfort in buildings, and increasing bulk density has a major role to play here. It reduces the porosity of the sample, which result in the less perforation, thus improving the absorption coefficient of insulation materials. The third article that I reviewed is named Sound Absorption Properties of Natural Fibers from year 2020. The items that they discussed in this article is the usage of natural fibers as sound absorbers can give a positive contribution to develop a competitive, resource efficient and low carbon economy due to the great advantages such as easy availability, lightweight, renewability, low CO2 emission, economical price and biodegradability. The fourth article that I reviewed name is Void Content, Tensile Vibration and Acoustic Properties of Kenaf or Bamboo Fiber Reinforced Epoxy Hybrid Composites from year 2019. For this article summary, the hybridization of woven kenaf and bamboo showed an improvement in overall properties. Hybridization of kenaf fiber with bamboo has improved the natural frequency compared to woven kenaf and bamboo composites. Based on the analysis, hybrid composites with a ratio of 50:50 of kenaf to bamboo were slightly better in terms of their sound absorption coefficient compared to other composites in the study of sound absorption of composites without an air gap. An article titled A Comprehensive Review of Natural Fiber Reinforced Composite and Their Modern Application from year 2023 is also have been reviewed to help this study. The items that they discuss in this article is natural fiber composites offer brighter materials than synthetic fiber composites. Despite having comparable levels of mechanical properties, the chemical treatment can be used to further improve the mechanical and physical properties of natural fiber reinforced polymer composites. Now I am going to explain about the flowchart of my study. After start the study, the preparation of bamboo fiber and palm empty fruit bunch PEFB by silent coupling agent method have to be done. Next, preparation of non-woven blended with bamboo fiber and palm empty fruit bunch at different ratios using needle punching machine have to be done. After that, preparation of laminated non-woven bamboo fiber and PEFB with flexible epoxy by hot press method. After that, we have to characterize the water contact angle of the mat. If the water contact angle is more than 120 degree, we can proceed to the next step. If the water contact angle does not more than 120 angle, we need to prepare the non-woven blended with bamboo fiber and palm empty fruit bunch at different ratios using needle punching machine again. By doing these steps, we actually achieve the objective 1 of this study. After that, we have to find the characterization of sound, vibration and thermal conductivity of non-woven blended with bamboo fiber and palm empty fruit bunch PEFB. By doing this step, we actually achieve the objective 2. After that, we have to do the comparison of sound, vibration and thermal conductivity of non-woven blended with bamboo fiber and palm empty fruit bunch PEFB with commercial insulation material. By doing this step, we achieve the objective 3 of the study. After that, we have to do the result discussion and finally the report. There are two main materials that used in this study, which is bamboo fiber and palm empty fruit bunch. There are 4 main steps in this study to conduct the research. Okay, the first step is treatment method of bamboo fiber and PEFB with and without silent coupling agent. Okay, so now let's see the procedure of bamboo and PEFB treated with silent coupling agent. Okay, the procedure is the first one is use the ratio 80 to 20 to prepare ethanol 99%, which is about 400 milliliter, and distilled water about 100 milliliter for 10 gram of cut bamboo fiber and PEFB. The second step is put 400 milliliter of ethanol 99% and 100 milliliter of distilled water and 0.1 gram of silent coupling agent into a beaker and put on a magnetic stir to form an even mixture. The third step is immerse the bamboo fiber and PEFB in the mixture for 3 hours. The fourth step is after 3 hours add 0.5 gram of acetic acid to it and mix them and wait for 1 hour. Then test its pH value to attain 6 pH using the pH meter. After that, arrange the treated fiber on an aluminium foil accordingly. Later, put it in the drying oven at 80 degrees Celsius for 24 hours. Well, now we see the untreated with silent coupling agent for the bamboo and PEFB. For this untreated, the first step is cut the fibers in the range of 6 cm to 8 cm and then insert the first proportion of bamboo fiber to PEFB fiber where the ratio is 100 to 0 into the needle punching machine. Okay, now after that, the second step is preparation of non-woven using a needle punching machine. The table shows the ratios of the PEFB to bamboo fiber. They are untreated and treated. Okay, for this needle punching machine, the first step is the bamboo fiber and palm empty fruit bunch fiber was prepared in the respective ratios based on the table. Choose a 100 to 0 ratio of the untreated bamboo fiber to palm empty fruit bunch fiber for the first sample. The second step is place 3 to 4 kg of bamboo fiber that was cut into the needle punching machine's feeding mechanism. Third step is according to the suggested parameters for the particular fibers being used, adjust the machine's setting. After that, start the needle punching machine and observe. The fibers had been penetrated by the machine's needles, which then entangled and joined the fibers to create an enduring non-woven mat. Finally, remove it from the machine. Then cut the sample for 1.2 meter long, 1.2 meter width and 3 mm of thick. Third main step is by using the hot compress method after we use the needle punching machine. In this hot compress method, the procedure is first cut the non-woven material to the required size and shape. Then set the hot press machine to 180 degrees Celsius temperature and turn it on to warm up the press. After that, put the non-woven mat on the hot press machine's bottom's plate. After that, place additional materials on top of the non-woven mat if they will be used to make the composite sheet. Later, place the non-woven mat and other materials on the top plate of the hot press machine. After that, apply 10 megapascal pressure and heat the mat for 10 minutes. Later, lift up the top plate once the set amount of time has passed. Finally, take the composite sheet out of the hot press machine's bottom's plate. There are 4 main testing methods after the non-woven mat had been hot pressed. The first one is water contact angle testing using contact angle meter, and then the second testing is sound testing using the impedance tube. After that, vibration testing, which is specialized in damping characterization using vibration transmissibility, and then the fourth testing method is thermal conductivity using heat flow meter. It has been expected that the thesis on non-woven mat manufactured from PEFB and bamboo fiber in various ratios have the potential to further the development of sustainable materials and offer knowledge about the characteristics and prospective uses of these materials. Thank you.